for joining us this afternoon. The first practical photovoltaic cells were developed in the early 1950s at Bell Labs, and they made their public debut in 1958 when Voyager 1 satellite carried them into outer space. At that time, the cost was, as you can imagine, astronomical. Since then, scientists and engineers have worked wonders. Since 1975, the cost per watt for photovoltaic capacity has dropped from over $100 to less than 20 cents. And Nick can probably tell us that it might even be lower than that now. It's expected to keep being lower. Even if we were not in a desperate race to reduce greenhouse gas emissions, solar energy would play an increasing role in our energy mix simply because it's cheaper. The Earth receives more solar radiation in a single hour than humans use in a year. But there's another equally important way we can think about solar energy. You'll often hear the words, but the sun doesn't shine all the time. True enough, but when it does shine, it shines on all of us equally. Solar power can be produced on an individual scale and at a predictable low price, getting us off the fossil fuel roller coaster we've all grown up with. This afternoon, we start our series of forums on electrical issues that everyone on the Blue Hill Peninsula is facing. In a nutshell, our electrical infrastructure must expand rapidly, must make major changes in its business model. We already have the technology to make these changes. We simply need to summon the will and the leadership to do so. Our first speaker is Nick Young from Sundog Solar, a Searsport company that specializes in small and medium scale solar installations. Nick works 5 days a week on the nuts and bolts issues that surround the kind of solar arrays that might go on your roof or in your backyard or on our municipal buildings. While we greatly appreciate Nick's help today, we must say that his appearance does not constitute an endorsement of Sundog Solar by either the town of Brooklyn or the Brooklyn Climate Response Committee. We know that you will have lots of questions today. After Nick's presentation, he'll be joined by Ken Colburn, who just came in, for a question and answer period. You'll find a very abbreviated list of Ken's qualifications in our program. If we listed them all, we wouldn't have time to hear him speak. Suffice it to say that if you have questions on how electric utilities operate, on how they must change, and on how we can help facilitate those changes, you're unlikely to find someone more qualified to answer them. So let's get started. Nick Young, thank you.
Okay. Thank you, Doug, and thank you everyone for coming out tonight, and thank you to the Brooklyn Climate Response Committee for inviting me to speak tonight. As Doug said, my name is Nick. I'm the Sales and Design Manager at Sundog Solar. We're a Searsport-based local company. We specialize in solar, EV charger, battery storage, and heat pump installations. We've been in business since 2009, and I personally have been at Sundog since 2020, so over 3 years now. When I started at Sundog, I knew absolutely nothing about solar, and I've learned a lot along the way, so I'm grateful for the opportunity to share some of that with you all here tonight. Oh, good start. Here we go. Okay, so I'd like to start with going over Maine's net energy billing program, some basics about it, and why Maine in general is good for solar. Because it is a common misconception that Maine is not a good place to get solar, and it's really hard to blame someone for thinking that. I mean, if you look outside right now, it's 4:30 and it's pitch black out. So that's a common misconception, but Maine actually has a lot of great policies in place that make solar very beneficial to Mainers. And that starts with Maine's net energy billing program, and more specifically, their 1-to-1 kilowatt hour crediting system. So the way that solar systems work is that you're going to be producing power from your solar panels and using some of that power for your active home loads during the day. Any of your appliances that are running, lights, stuff like that. And the remainder, what you don't use, gets sent to the grid and credited to your account. Now, in a lot of states and other places around the world, you don't get the full value of that credit. So if you produce a kilowatt hour and feed it into the grid, you might get 40%, 50%. In Maine, you get 100% of the value of that credit. So it's very beneficial. Those credits also last 12 months from when they're fed into the grid. And that's on a rolling credit system. They don't reset at the same time every year. So for example, any credit that you produce in July will last until July of the next year, so on and so forth. So what we do is we use that to size solar systems in a way that you're going to be producing a lot more than you actually need during the summer months. You'll be able to tap into those credits during the winter months. So we produce a lot more than you need during the summer, and then it all balances out to get to what we call net zero, or a full offset of all of your electricity needs. Now, this also locks in your price for electricity. So like I said, it's at 100% of the value of the credit. And even if rates go up, then the value of your credit stays the same. So you're essentially exempt from rate increases. Another good benefit here in Maine is account cascading. So what you can do is you can actually share credits to multiple accounts in your name, so long as they're in the same service district. So if you have two properties that are in Versant territory or CMP territory, what you can do is you can have one array feed both of those properties. So those credits will go to your other accounts. Now, this is beneficial if you have multiple properties and one has a lot better solar exposure than the other. It's also great for businesses because you can put a solar system on, maybe you have a business with a large roof and residents with not a large roof. You can put solar panels on your business roof and then offset the credits for your residential property as well. Of course, it's a renewable and inexhaustible energy source. The world is always going to need energy, and you might as well create your own and take advantage of Maine's great net energy billing program to do so. There's currently a 30% federal tax credit in place. So that is a credit against your tax liability, and it's worth 30% of the value of the installed price of your system. So you'll file for this at the end of the year against your tax liability, and it lasts until 2032, so it rolls over. So if you can't take advantage of the full credit in the first year that you install your system, you have plenty of time to take advantage of that credit. There's also currently a 50% REAP grant available from the USDA. And this is for rural businesses. So if you have a business, no matter what it is, you can apply for this credit and get a 50% grant from the USDA. Now, that's not a credit, it is actually a grant. So both of these working in tandem with each other, and all of these net energy billing policies make Maine a great place to go solar. So what does it cost and how many panels do I need? Well, that is a tricky question because it all depends. It depends on your energy needs. Two different people, two different properties will have very different energy needs. So if you have a four-person residence versus maybe you live by yourself, those two homes will need a vastly different amount of solar panels. But on average, the average home requires about a 6 to 8 kW system, and that's about 15 to 20 solar panels. So that would be a 400-watt panel, which is the standard these days, around that size range. But the panel sizes actually vary greatly, go down to 300 watts or even smaller, all the way up to 500+ watt panels. So the price for that, again, varies greatly. So anywhere in the range from $20,000 to $25,000 for that 6 to 8 kW range system. There's a lot of determining factors, including, the panel manufacturer, the inverter manufacturer. Some panels carry a longer warranty or have a higher efficiency rating. Those are going to be more expensive. And you can also, of course, get a roof-mounted system or a ground-mounted system. Speak more on that in a bit, but those prices vary as well. It's also important to note that two homes that have the exact same energy usage might need vastly different solar system sizes. And the reason for that is because one home may have a perfect roof for solar, south-facing with no trees, while another with the same exact amount of usage might have an east to west facing roof with some shading. So even though they have the same energy demands, they might need different size solar systems. So when we're sizing a system, we're looking for a southern facing roof because the sun follows the equator. So we want to face towards the sun at all times. East and west isn't going to make or break your system, but we're looking for as close to south as we can. And of course, as little shading as possible. Now, for a system of this size in the 6 to 8 kW range, you can expect over the lifespan of the system, 25 plus years, that you'll save upwards of $50,000 on utility costs. So that takes into account a couple factors, including the 30% federal tax credit, rising utility rates, inflation, and most solar systems these days offer a 6 to 10 year payback. So anything in that range is ideal and what you can expect. But $20,000 to $25,000 is not a small amount of money. That's a lot of money for a lot of people. So of course you can always get a solar loan. And there's pros and cons to each. So if you have a cash purchase system, you purchase it outright, it's going to take longer for you to start getting your investment back. So that 6 to 10 year payback, that's how long until you start making your money back. But if you get a loan, you can replace your monthly electric bills with a loan payment that is lower than your electric payment. And then you start saving money right away. Of course, you're accruing interest. So over the lifespan of the system, your overall savings is going to be a little bit lower, but it's a great option for starting to save money right away. So how do we decide what system you need? Well, this is a very sped up video of our modeling software, Aurora. This is me designing a home. So these days, a lot of it is done remotely. We have a powerful modeling software called Aurora, and it's the gold standard for solar modeling softwares. And what it does is it uses LiDAR to determine your roof shape, dimensions, pitch, any possible obstructions. So we can do all of this remotely. So this shows me all the dimensions of the roof, and I can tweak the design accordingly and put panels on it. It also shows, of course, the trees that are in the area, so we can model those as well. So this is it has two different views. This is the dot view, which allows us to have a more accurate measurement. So it'll show us all the dimensions of your roof. And then it uses the previous 2 years of weather data for any location to determine how much production you can expect on each month during the year. Even has a daily breakdown, shading analysis, and stuff like that. So what we'll do is we'll model your roof, we'll put panels on it, and then we will tailor that to fit your needs. And we'll ask for a copy of your electric bill to determine how many panels you need. So on the first page of your bill, be it Versant or CMP, there's a bar graph that shows your daily usage over the last 3 years. So we take a look at that, determine how much your annual kilowatt hour usage is on average, and then we'll size the system accordingly. So I'm not going to let this whole thing play, but it also shows, a radiance so we can determine the best roof face in your particular situation. So if you have a roof with multiple roof faces, roof pitches, we can use this to determine which is the best roof to use for you. So there's two different options when you're considering going with a solar system, roof and ground mounted systems. And there's pros and cons to each. So starting with roof mounted systems, the big pro there is that in general, it has a lower upfront cost. So if you had two identically sized systems, say both 8 kW systems, one on the ground and one on the roof, almost always that roof mounted system is going to be less expensive because there's no groundwork required for a roof mounted system. A little bit less labor intensive, and the racking system for the roof mounted systems is typically less expensive. So that's a good way to save some money. Just go with a roof mounted system. Of course, it doesn't take up any extra space on your property. Some people don't want a large solar system taking up space in their yard. So what you can do is utilize roof space that's not being used for anything else to put solar panels right on your roof. There's also less permitting requirements for roof mounted systems in general. Now, any solar installer that you work with is going to handle the permit on your behalf, so it's not really something to worry about. And Maine is actually very good with permitting, but from time to time, you can run into some issues with ground-mounted systems and permitting, especially if you are on the coast or near a body of water that has some more strict permitting requirements. It'll actually protect your roof from the weather. So if you have panels on your shingle roof, any roofer wants to tell you that the shingle roof will last 25 years in Maine. maybe if you're lucky, but you can protect your roof and extend the lifespan of it, protects it from sun exposure and the weather. So that's a little added bonus to having solar panels on your roof. Of course, there's no roof penetrations if you have a standing seam metal roof. So we get this question all the time, what's the best roof for solar? There really is only one answer, and that would be a standing seam metal roof. And the reason for that is that with any other roof type, asphalt, corrugated metal, cedar shingle roofs, we have to make roof penetrations. So they are completely watertight, but some people understandably aren't too excited about someone going up there and poking holes in their roof. So if you want to avoid that, you can have a standing seam metal roof. And what we'll do is we'll actually clamp onto those seams instead of having roof penetrations. And it also costs a little bit less money. It's less labor intensive. So that's a good option if you don't want penetrations in your roof. Now, what about ground mounted systems? Well, these are ideal for roofs that don't have good solar exposure. So if you have a roof that's not south facing, has a lot of shading, but you have a big backyard, you might want to consider having a ground mounted system. We can also set it at the optimal angle for solar output, which is about 35 degrees. It's 35 degrees in the summer for Maine. Again, we're going back to that kilowatt hour crediting system. We're trying to make the most out of the summer months. So we tilt the angle to about 35 degrees and we can face it perfectly south. So you might have a roof that even though it has good sun exposure, you have a very low pitch. Well, we can decide that pitch when we install our ground mounted system. It's also very easy to access a ground mounted system for repairs. If you have a panel that's down or not producing properly, it's a lot easier to just walk up to a ground mounted system and take a look from the back than it is to go up on a roof, start pulling panels off and taking voltage readings. So that's a lot easier to access for repairs and general maintenance. Of course, there's no roof penetrations for this. No one's up there poking holes in your roof. And it's a lot easier to scale than a roof mounted system. So if you're planning for adding electrical draws in the future, maybe you want to add heat pumps and an EV charger, but you don't want to wait to get solar, you can easily upgrade a ground mounted system by just extending the racking system, adding more panels. It's a lot easier than doing so on a roof. You also don't have to worry about replacing your roof. So of course, if you have solar panels on your roof and you need your roof replaced, that is an added cost. That's something that you do have to take into consideration. Someone has to go up there, take the panels off, and then put them back on when your roof is replaced. You don't have to worry about that if you have a ground-mounted solar system. So some steps toward energy independence start with solar modules, more specifically, a solar array in general. So solar modules convert photons from the sun into DC power for your home loads. But most homes use AC power for their loads. So what we do is we put an inverter, it's called an inverter, on every solar system, and that converts the DC power from the panels into AC power for your home loads. So there's two types of inverters that you can go with, being string inverters and microinverters. And the main difference there is a string inverter would be one single inverter for all of your solar panels. So they all go right into this one inverter. And then a microinverter system has a smaller inverter on each one of your panels that are all combined into a box. So there's some pros and cons to each of those. Microinverters generally have a longer warranty and are a little bit more reliable. They are a bit more expensive, but at the same time, if you have your inverter fail, then you don't have to worry about your entire system going down. You'll just lose one panel, easy to repair, whereas a string inverter, if you lose your inverter goes down, then your whole system goes down. But in that same vein, microinverter systems have more points of failure. So there's pros and cons to both, but they're both great options. One last piece of equipment that might go on a solar array is what's called an optimizer. So microinverters already have those built into them, which is another benefit. What optimizers do is they reduce the impact that shading has on your array. If you don't have those and there's even a minor amount of shading from a tree branch on one of your panels, that's going to affect your entire array. And we just add optimizers or maximum power point tracking devices under each one of your panels, and that will allow you to reduce the impact that the shading does have on your array. It's pretty much all that goes into a solar system. And after that, you might want to consider adding some sort of energy storage system. So there's a few benefits to having an energy storage system. Of course, it basically acts as a generator, a renewable generator that you can charge from your solar array. rather than having to go with a propane generator. Another benefit to having a battery storage system is that when the grid goes down, another common misconception, when the grid goes down, you lose power and you don't have an energy storage system, your solar array is going to turn off. And that's required by law to prevent power from feeding back into the grid while workers are making repairs. But if you have an energy storage system, it acts as a sort of gateway between the grid and your solar system. So you can send the power to your energy storage system, your battery, and then continue to pull from that during the day. So that has the added benefit of, even though it might have 10 kilowatt hours of storage, your solar panels can continue to charge that, effectively giving you a lot more, so you can continue to charge that during the day. Then you might want to consider heat pumps. Really, any electric heating source pairs very well with solar. We install mini split heat pump systems because they're highly efficient and they work very well with solar arrays. So Efficiency Maine has a lot of great rebates available for heat pumps. They recently changed their structure, and for whole home heat pump systems, you can get up to $8,000 in rebates. It's a little different for commercial applications and for multifamily units. So multifamily units, you can get up to $10 per square foot, which is a huge benefit and save you a lot of money. So it's not like the federal tax credit, whereas it's a credit, it's actually a check that they'll send you. But there is also a federal tax credit available for heat pumps. That's at 30%, but it is capped at $2,000 per year. So up to this point, you can have all of your energy needs met as well as your heating needs met. And the next step after that would be consider an electric vehicle and an electric vehicle charger. So this will allow you to also have all your transportation needs met. So that's very beneficial for numerous reasons, and we can actually calculate how much power that's going to draw. So if you tell us you're considering adding an electric vehicle charger, or maybe you just added it and you want solar panels, all we really need to know is how many miles you drive in an average year. So on average, it's going to take about 300 watts of power to charge an electric vehicle for 1 mile. So if you drive 10,000 miles in an average year, that's going to be about 3,000 kilowatt hours that we have to account for. So all of that sounds good. If you have all 4 of these, then you have all of your needs met through solar energy. But there's always a catch, isn't there? So the catch is that you can't just put solar panels on your roof and start sending power to the grid. You have to apply for it. So you apply either through CMP or Versant to participate in the Net Energy Billing Program. And I'm sure a lot of you have heard throughout the last year or so on the news that some people are getting shut down. They are being denied interconnection. Now it's gotten a lot better over these past few months, but it is still something to take into consideration. What you're seeing here is Versant's publicly available hosting capacity map. Now, this is available to anyone. You can just look it up, their Versant hosting capacity map. You can look it up and you can see what your road looks like, whether or not you can get solar or not. So at the bottom right there, you'll see that key that shows the remaining estimated hosting capacity. So a whole lot of colors here. This is Bangor. So some streets are red, which means maybe not a lot of space left on the grid there. Some are green, which means there's a whole lot. But this is Brooklyn. It's all red. So that's one issue. But another issue that we're seeing here is, yes, it's all red, but that doesn't mean there's necessarily zero capacity. So at the bottom right there, you'll notice it says under 199 kW. Well, what we're looking at here could be 198 kW, or it could be zero. And the only way to find out is to apply for interconnection, which again is not as easy as just asking Versant, hey, can I put panels on my roof? You have to go through a pretty lengthy process that takes a lot of engineering documents and engineering effort. So it's very unfortunate to go through that whole process just to find out that you can't get solar. So earlier this year, we applied for interconnection for 2 Brooklyn residents. And one of them is here, and they passed in this general location to the west of Brooklyn. And the other one is to the right and to the east of Brooklyn, and they failed. So the reason for that is that there's actually 2 circuits that you're seeing here in Brooklyn. And when you go on this interactive map, you can click anywhere on here to see what that circuit is. On the right here, that is called BL2, and that we know has no remaining hosting capacity. I have my little laser pointer here, but I don't think you can see it. But towards the bottom there, right near where it says Brooklyn, there's a little cutoff, and that's when you get to BV2. The cutoff is a little bit easier to see towards the top there. So everything to the left, all the way down to Deer Isle, is a different circuit. So you have two different circuits in Brooklyn. That one, as far as we know, at this time, still has some remaining hosting capacity. We know that because recently we used the information that we gathered from the project that passed over here to apply for a project in Deer Isle, which passed. But it's not a perfect science because we could have used up the remaining hosting capacity on there, and we have no way of really knowing. The only way to know is to interconnect. Versant has started to be a little more open about what circuits are down. It used to be trial and error. We connect to a circuit and then we got shut down. And then we know, okay, we can't connect to that circuit anymore, but they've been a lot more open about what circuits have no more remaining hosting capacity. Whereas before it was just trial and error and, speaking with other solar companies and seeing what their experience has been. So things are getting better. It's now easier now more than ever to file an informal dispute with the Public Utilities Commission. This is kind of a last-ditch effort to get some more clear answers. So you can just simply go online, file that informal dispute, and have someone take a personal look at your application to see what they can do for you. So things are getting better. It's going to be a slow process to get there to where anyone in Maine can get solar. Unfortunately, that's not the case right now. And being a Brooklyn resident is a little tough if you want solar these days. But we're just hoping for the best and optimistic for the future. Thank you guys so much for listening. That's all for me. And I'm happy to answer any questions you may have. Yes.
Nick, for persons who have applied for a connection agreement and the application gets denied, does that application remain open and can you leave it there and all of a sudden somebody may call you up and say we have an opening, or you have to keep pushing?
Ken, is that in your wheelhouse?
I'm sorry, I was just checking. I didn't see this when I came in, so I was
You guys
momentarily
use this money.
diverted. Can you repeat the question?
Yes, if you had put an application in with Versant for a connection agreement and you've been denied, does that application remain open and valid? Oh, and someone will get in touch with you perhaps if it does become possible, or do you have to keep applying and applying and applying?
I don't know the actual answer to that, but the de facto answer to it is you should manage your application. If they tell you no, they probably consider that the end of the story. Whereas you wanted to say, well, improvements are happening continuously. I saw some trucks in the neighborhood the other day and it wasn't an outage. So I'm calling back in and they may tell you you have to reapply. I'm not sure about that iterative process. In general, I'm sorry to say, you should assume what is the worst answer you could get, and that's the probable answer that you should proceed with. Our utilities are not rated the worst and the third worst in the country for no reason.
Oh my God. I happen to be the guy on the right.
Yes.
So I want to make certain that the persons who are handling my application, meaning Nick and his crew, keep my application visible to these people and hopefully at some point in time they'll say, okay. But
That is another good answer, is to depend on your vendor.
Talk to you tomorrow.
Engineering documents do you need?
So we need to submit, so she asked what sort of engineering documents you need to submit. So what we need to do is we need to, first, the easy part is there's some applications that you submit. Just needs your signature and your solar installer can fill that out for you. It includes information about your system. But additionally, you're going to need an electrical diagram, ideally done by an engineer. Back in the day, we had some pretty rudimentary drawings, but the criteria is a lot more stringent these days. So you'll need that. You'll also need a site plan of your property, equipment data sheets. So if you are capable of filling out all of that yourself, you can absolutely fill out your application. Most people need to rely on some sort of expert, and there is a $100 application fee.
And you're the expert that would fill it out, correct?
That's right. Your installer will fill that out for you. Yes, sir.
So I have a system here in Brooklyn that is in fact on a net meter system. It was installed about 10 years ago
Mhm.
by another company that sounds like Provision. And what I'm wondering about is something that I've thought I've read in the news, and maybe it's more national, not local. And that is that when the power goes out, that there's some way that you can in fact still use the power that's coming from your system, that there's something that you can install that will switch things over without having the whole system shut down. Is that correct, or am I misinformed about that?
So he's asking if there's any way to continue to use your solar system when the grid goes down. So I did touch on battery storage. That is the only way to do it by code in order to prevent power from backfeeding into the grid. So you will need some sort of battery storage system somewhere for the power to go. Because if power goes to your active home loads, there's nothing stopping it from going straight to the grid. So yes, you would have to have some sort of energy storage system. Yes.
Do you use like a car as a battery?
She asked if you can use a car as a battery. Yes, you can. So it depends on the car you get. I think Ford Lightning does this, and you need a bi-directional EV charger. So any old EV charger won't do the trick. You need a bi-directional one, which can power the car, but also pull charge from your electric vehicle's battery and then power up your home. That's a great alternative to kill two birds with one stone, have an electric vehicle and also have a battery backup system.
Yeah, if I can just add to that, currently Ford has that capability and a couple of other manufacturers do. All of them are working on it and all of them soon will, for two reasons. It makes their product more attractive, obviously, but also it makes it more functional for the grid. Because whether or not there's an outage, there's periods of high demand and low demand. And if they can turn to your vehicle, because you don't need it at the moment, it's midday, whatever, or you give them permission. If they can use your vehicle instead of going to Boston to get more power, they can do that and hopefully compensate you for it. So this is one of the ways the market is dramatically changing in power. Doug was kind enough to print a bio. Perhaps I should add to that, that the system itself is undergoing dramatic change. And for the last 100 years, we have managed the grid, which has to be balanced between supply in and demand out. Moment by moment, we've managed it by turning the knobs on the power plants. Well, you can't turn the knob on solar and you can't turn the knob on wind. So we got to do something else. Storage is going to be a big help on that, but we're going to turn knobs on demand. So we're going to charge EVs when there isn't much demand, and we're going to maybe use EVs when there is a lot of demand. We'll use devices to manage the grid much more than we have in the past.
So I have a quote from Sundog I appreciate, but I wasn't clear about the steps. So say I want to apply, would that be the first step, that $100 application fee, or would I actually try to do a contract first with it says a 30% deposit. So in my mind, you'd want to get approval first from Versant before you undergo a contract with a deposit.
So in our case, Sundog, we asked for a 30% deposit to get started on everything. And that includes your utility application. And the reason for that is that the $100 fee doesn't really cover everything. There's a lot of engineering effort that goes into doing your application from our engineering team. but it takes hours of work. So we do ask for a 30% deposit to get started on that, as well as your permitting, order all your equipment. So we do all of those in tandem, including your interconnection application.
So if they refuse, to go forward, you're denied, in other words, then, you might lose 30% of the overall cost that you've invested, right?
In our case, our contracts at Sundog Solar, if you are denied interconnection, we return your deposit less $1,000. So that covers all of our expenses.
I see, so it's an $1,100 investment, really, if you're.
1,000, we cover that application fee for you, so that's included. So if you get shut down, you cancel your contract with us for any reason whatsoever, $1,000 is what we hold.
Okay, and I have a second question. So today I was busy cutting down trees, but I have offset that with planting new trees because I feel so guilty. But these were like no-brainer trees that would interfere with solar panels on the roof. But I didn't go 60 feet out because it's very expensive to have an arborist cut down trees to get that kind of effect on that you need. So, does anybody ever qualify, yes, you really need to cut down the remaining trees within a 60-foot swath?
Yep, so she's asking about tree clearing around your array. That's going to depend on the height of your trees. So what we like to do is we like to take a look at your property remotely and utilize that program that I just showed you. But it's not perfect. We do like to come out on site as well. So we can take a look remotely first and see what trees might be tricky and what are causing the most shade on your home. And then we can come out and show you those trees. So we understand that not a lot of people want to cut down a whole bunch of their trees. So it's a careful balance that we play with that.
Okay, thanks.
Yes, sir.
Looking at the Brooklyn grid and the difficulty of getting into it, what needs to change for it to become easier to connect in Brooklyn?
The question is, with the Brooklyn grid, pretty constipated and all red as next picture showed, what needs to change? A lot.
Okay, so what is it?
It would be illuminating, for example, to indicate that Versant just barely put up those hosting capacity maps, and they're pretty static. A lot of even smaller utilities across the country are putting up dynamic hosting capacity maps. So you could tell, even week to week, what's the circumstance. There are two arguments here. One would be that Versant and CMP need to get the thumb out and get going and understand the state's goals and act in concert with them. The other side of the coin is the grid was designed and built to be a one-way transfer of power from the power plants to you. And now you're asking it to do something it wasn't designed and built for. So it's going to have to be upgraded. Upgrading costs money. We, Versant, we, CMP, are in front of the PUC asking for more money. So we hope you'll support us in that request, which will result in higher rates. It's really one of those stop, you're both right questions. But there are efforts underway at the PUC to alter the rules that relate to these types of installations, to have them be socialized, which is to say, everybody in the state, everybody that's a customer of the utility, particular utility, will help pay for those grid upgrades. Otherwise, you may have to pay for a grid upgrade, if that will even be sufficient. If it were your local transformer, you might have to buy a new transformer. It would add like $3,000 or $4,000 to your price tag and might cause you to not do it, but at least you'd have that option. In Brooklyn, because of the state of the overall grid, even that may not be possible. Bottom line is the utilities will need money to improve the grid enough to do this. And that's probably not a short-term fix, but you got to keep the pressure on so that they can do so and will do so.
So what I'm hearing is you need physically to upgrade the grid in Brooklyn before it's freed up to the point where you can really add.
Yeah, the follow-up was, so we need to physically improve the grid in Brooklyn. The short answer, or overall answer, is yes, but as Nick indicated, there's at least 10 to 15 sites that are possible even below 200 kilowatts, right? So there is some room. On top of that, even though the overall grid is in not great situation, it might be that improving a transformer here or there would change the zeros to 200s and allow room. So there's likely to be small improvements in small sections of the Brooklyn grid that could be upgraded enough to make more solar possible. How you find out that is itself a tricky question. I would once again go to my Sundogs or vendors to push in that direction. And you can't always go to the PUC directly as a citizen.
Is going to the PUC the only way that pressure can be applied to the utilities? Is Sundog applying pressure to the utilities? Where is the pressure coming from at the moment, and how can it be increased?
Yeah, the question is how to pressure the utilities to get about this task of fixing the grid. Sundog and other vendors have a tricky role here because they depend on the utilities and cooperation for the utilities to be able to install anything. So they don't want to get on the wrong side of the utilities, understandably. At the same time, they're working for you all. So they want to push forward. So they do a delicate dance of, push, pull, push, pull. The rest of the pressure, the most pressure, I think, is coming from policy. Maine has set reasonably aggressive climate goals, and we want to meet them. And one of the ways we're going to meet them is through renewable energy, which, the one closest at hand is solar, the way Nick described. So if that's a policy question, well, that's the domain of the governor and your legislator and the PUC. So I would write them all. Every citizen has an opportunity to submit comments, not only on bills, but on PUC dockets. And there's web-based ability to comment. You don't have to go anywhere, or, show up at a certain time or any of that. You can submit comments. So I don't have a better answer than, how to really apply pressure than the normal citizen stuff in a democracy. But it's working in Maine slowly but surely.
Yes, ma'am.
Is there any way a residential customer can have solar in the absence of a relationship with CMP or Versant? I have a home that's 700 square feet. So is there a way that I could have solar power and not have a relationship with Versant?
So the question is, can you have solar without a relationship with Versant or CMP? And the answer is yes. That would be an off-grid solar system where you are not tied to the grid whatsoever. Unfortunately, it's a very expensive solution when compared to a grid-tied system. There's a lot more components that go into it. It's more of a lifestyle choice than it is an investment, as solar is, because of the high upfront cost. But the short answer is yes, you can be disconnected from the grid. You don't have to be connected to CMP or Versant's grid, but you'll have to make some lifestyle changes or buy a very expensive system in order to do that. Yes, sir.
How widespread is this connectivity problem in the state of Maine, especially along the coast? I mean, are there similar problems in the mid-coast or, around Belfast or other places?
So the question is, how widespread is this problem with interconnection? Fairly. So we have identified upwards of 10 or more circuits that do not have any remaining capacity. One is the one I showed you, BL2. The one right above that is BL1, which is Blue Hill. There's also a circuit we've identified in Hamden, Surrey, as well as there's quite a few circuits that do not have a lot of capacity, and I'm not sure if that information is actually publicly available to anyone. But I will note that to date, we haven't actually had a shutdown of a small project in CMP territory. That's us personally. I can't speak for other solar companies or other people's experiences, but any smaller projects have not been shut down in any CMP territory.
In some respects, to get an upgrade in Brooklyn, we're competing with all kinds of other entities along the coast and perhaps similar.
the question is, so Brooklyn ends up competing with other jurisdictions and towns to upgrade the grid. In terms of there being limited capacity in a utility to make upgrades, yes, that's true. I don't know what their decision-making algorithms are, but that's another case where citizen pressure probably can't hurt any. And I would say, in response to the first question about how big a problem is this, it's not just down east. It's not just mid-coast. It's not just the whole state of Maine. And this is probably the single largest complaint that citizens have about the power grid, with a possible exception of rates that exist. And beyond Maine even, it's a national problem. And it's not even small scale. Lots of major installations, even want to put in, say, fossil fired power plants and so forth, have to get in line and do exhaustive studies to get onto the grid. And this is a bottleneck that is a problem across the country.
Yes.
I have a question, but I thought I'd seen some hands further in the back earlier. Molly, did you have a question?
It's been answered, so.
Okay, and you?
Yeah, my
Please.
question was basically answered about what the Versant needs to do to make it so these redlined areas can connect, but I'm curious, what is the problem? Is it the substation? Is it the wires? You know, I'm not an electrical engineer. I just wondered what's going on in our grid.
The question is, what exactly is the problem that is making Brooklyn's grid all red? This may be a case where Nick is actually in a better position than I to answer, but he's also got to keep at least partly on the good side of the utility. So let me at least put forward a couple of thoughts on that. Utilities often put in conductors that are too small. You may have a 200 amp circuit box in your house, but the utility knows you're probably not going to really use more than 75 amps or something. You know, your refrigerator can do 4, your water heater can do 4. You know, there's 8. Lights are light. You're probably not going to use 20 or 30 on a regular basis. Well, now you want to put in solar, you want to put in an EV. You might be getting up close to 200, but they put in a wire that was big enough for 75 or 100. So now you got to run different wires. Well, transformers are similar, kind of undersized, because what are people really using? And you can kind of understand this on the part of utilities, because putting in bigger wires is more expensive. That means the rates are going to be more high, right? So they lowball to keep costs down, but it is lowballing. Then there's other issues like their capacity internally, and how many people do they have looking at your interconnection applications, and what's their inbox look like, and how rapidly do they go through it, and how much can they wait and let pressure build so that they can go to the PUC and say, see, we really do need a rate increase. So there's almost no part of this, you know, elephant that you can look at and not find an answer that's actually true. I wish I had a single bullet that I could advise you, you know, target here and shoot and you get resolution, but it's probably not going to be that easy. So coming to meetings like this is a great start.
So what would happen if a bunch of citizens from Brooklyn donated a whole bunch of money and walked out with $100,000 check and said, okay, we'll look at the transformers, we'll look at the wires, we'll pay for new ones, will you now connect us? Is that a possibility?
The question is, could we self-fund some of these grid improvements? I don't know of any circumstance where that's happened. That doesn't mean it couldn't be done. I can tell you it would probably be 7 figures rather than 6.
Okay.
But, you know, that's just an addition of a 0 on the end, right? It may not be impossible even then. And it probably couldn't be done easily for the whole grid. But one of the things these hosting capacity maps can show, you know, apart from just the colors, is where are the real bottlenecks that affect the most people? Sort of like when there's an outage, right? They're gonna fix the things that have the most people at the end of them. And if you are the only guy at the end, that's probably gonna get fixed last. They can do that with power flow as well. So, you know, you might wanna vet that question with the PUC, with an energy attorney, you know, get a little better legal smarts on it than Nick and I offer. But I would not say no.
If we all go solar, does that put Versant out of business?
Probably not. I'm sorry, the question was if we all go solar, does Versant go out of business? Probably not, because we want to maintain the benefits of the grid, which is when you could be down, but say you have got an EV and you got heat pumps, and there are times when you use more energy than your solar. You want to have the grid there to back you up. And if you're all solar and you all have storage, then that still exists, and you may be drawing from your neighbors in what's called a microgrid. And that's I think, a really good way to go. That way you can balance each other. You can protect your school, your fire department, you know, your police station, over individual homes to make sure your municipal services keep working. They will still be the custodians of the poles and wires, and we'll have to pay for that, as we should. They just won't be the marketer of the power per se. So there's still a life. In fact, there's one representative from, I believe, York, Jerry Runte, who has proposed the establishment of a distribution services organization to manage Maine's grid. This is not a Pine Tree Power kind of takeover thing. It's just look, you guys aren't generating the power anyway, we buy it. Let people make it, but we still need you around to balance it and ship it here and there. Let's make that your job going forward. That's basically what the bill is, what it was called for. It's sort of like what you're asking. Nick, anything?
What was that called again, that bill?
It's referred to as a DSO, Distribution Services Organization, and that comes from the fact that FERC, the Federal Energy Regulatory Commission, required regional transmission organizations back, 2000 or thereabouts, so that there'd be greater sharing of power resources across states, rather than have everybody have their little fiefdoms that end up costing citizens more because of all these little fiefdoms. Well, we still have fiefdoms for distribution utilities, CMP versus Versant versus munis versus co-ops. Let's break that down the same way as FERC's requirement that created regional transmission organizations did interstate. What are we going to do intrastate?
So I have another question that has to do with all the heat pumps and the various other electrical ways to run appliances and so forth. Are those affected by connectivity to the grid? If we all transform our propane run appliances and heating to electric, is there gonna be a problem with the grid like there is with hooking up solar?
That's a pretty insightful question. The question of will greater electrification lead to additional problems with the grid? And that really, the short answer is probably. And the long answer is it depends on how well we manage it. If you look at electrifying everything we need to electrify, which is mostly at this point buildings versus heating oil, and EVs versus gasoline and diesel, then that is an amount of energy that some have estimated to be 3 to 4 times our existing energy use. Now you could say, okay, so we're gonna need 3 or 4 times the grid, right? Wow. We're not talking billions, we're talking trillions, even in Maine, when we're talking that kind of number. Maybe not trillion in Maine, but getting pretty darn close to it. Well, wait though, we built this system to deliver peak power. Peak power is about double average power load. So if we managed our demand right, the way I was saying, and charged our EVs at the right time, we could fit twice as much power in now. Okay, well, so maybe we only need to build the grid a little more than it is now, or 1 time more than it is now, as opposed to 3 or 4 times what it is now. So it really depends on how well it's managed. One way or another, it'll probably be expensive. And one thing Nick didn't say, but I will in his stead, is there is probably no better time to do solar than now, if you can possibly swing it, because of the 30% tax credit, and rates going up because of greater electrification, greater grid needs, fixing Brooklyn's grid. They will continue to rise. I should have indicated, and I didn't tell Doug this, so there was no way for him to know, but I'm not just an advocate, I'm accustomed, the hair growth stuff. I'm a net meterer in Bar Harbor, and I had the good fortune to put it on when I was building my house, so I could roll it all into the overall house costs. Added a little more later, and then became a member of the Bar Harbor Community Solar Farm. So I have 12 kilowatts total. And I heat with heat pumps. I had a little bit of propane because this was 2013 heat pumps, so they weren't quite as good as today's are. They don't go as cold, it still works. A little bit of propane, and I don't yet have my EV. But my heating, lighting, energy costs at this point, apart from gasoline, are $200 to $300 a year. So it can be done, it can be fruitful. It's not rocket science, it's what Nick's executing on a day-to-day basis.
So can I follow up on that? The question that I asked was very general, but it relates to me specifically. I do a lot of the heating with a water system, hot water system that's run on propane, that is about what you pay in a year, I pay in a month, and is there some way to heat water with electricity that would avoid the propane?
Yeah, the question is, are there heat pump systems that'll dovetail with hot water home heating systems rather than air sourcing? And this is a wonderful question that Efficiency Maine is working on now. They have a pilot or two. I think they're commercial rather than residential, but they're looking at a couple of commercial sites to pilot this. They're called hydronic heat pumps. They are out there. I think as a board member for Efficiency Maine, I think we need to be a bit more aggressive in our piloting and try to get this stuff out, assessed and out, hopefully with a rebate of some sort, an incentive of some sort, to provide exactly for people like you, so that we can convert domestic hot water systems, hot water heating systems, to heat pumps more rapidly than will otherwise occur just by dint of the
So
market.
this number 6, heat pump water heaters and rebate and everything is not in fact in effect?
Heat pump water heaters are in effect now at this point, and that's been a success story. But that's for your hot water to your sink, hot water to your
That's
dishwasher.
domestic heat.
It's domestic hot water. Now, of course, if you had the good fortune to have a hyper insulated home, some of those actually have as their heating source a domestic hot water heater. But that's not most of us. But that shows you what insulation can do. And energy efficiency is always job one. It's lower the bar, lower what you need, and then provide it.
Thank you.
What about using something like a generator? I mean, if you've got, one has an electric generator now, is there some way of interfacing that with, I don't know, later on a solar system? I mean, it's a little bit.
Yep, so the question is there any way to integrate a generator with a solar system? The answer is yes, and it's a very easy process. So if you don't have a generator, we're going to connect it to your home loads in a number of ways. We can connect into your meter disconnect. We can connect right into your main service panel. If you have a generator, we need to be upstream of that. So the reason for that is that we can't have AC loads feeding AC loads, solar feeding your generator and vice versa. Also, that inverter needs a way to tell when the grid goes down. And if we're not upstream of that generator and your generator kicks on, well, there's nothing stopping the inverter, and then the inverter will continue to feed in the grid. So that would not be up to code. So what we do is just tap upstream of that. We make our connection upstream of your generator. That can be done before or after the solar installation. It's a pretty straightforward process. That's one of the most common ways that we connect solar systems.
Yeah, I think I have a clarifying question that was part of the generator question. So just to clarify, like when Kate asked, can you completely be not relying on Versant at all? So when you talk about the Ford F-150 Lightning or a battery system, is that what you're referring to, or there's something you still have to be involved with Versant if you have those completely, if you have a storage system? Are you talking about something separately even from that?
Okay. Yep. So the question was, if you have battery storage, is that separate from being off grid? And the answer is yes. So you can still be tied to the grid with a battery backup system, and that's going to be most applications for a battery backup.
So you can still be denied right now if you plan on having a battery backup system.
So she asked if you can still be denied if you have a battery backup system. So when you get shut down by Versant or CMP, what they do is they fail your project and allow you to pass as what's called a level 3, which means non-exporting. So they're not actually saying you can't put panels on your roof. What they're saying is you can't feed power into their grid. So a way around that would to be install a battery. So you can utilize that to still charge your battery with solar panels. You just can't put anything into the grid. So you can charge your battery, pull from it, charge it, pull from it, and then that's a little bit a good way to get some production, but you can't take advantage of Maine's net energy billing policies if you get shut down as a level 3.
Related question, can you forecast sort of the pricing on the batteries? I know they're pretty expensive these days. Is that sort of expected to go down like panels?
So he's asking about the price of batteries and what we forecast. We have seen the price start to go down. It was going up for quite a while there, but we've had a couple price drops. We work with Tesla. We're a Tesla certified partner, but we also have a bunch of different battery backup options. Across the board, they're going down, but they're also improving the technology. So you'll have a new version come out. The Powerwall 3 is coming out soon. So technology is advancing, price is going down a little bit, but overall, it's pretty stagnant right now.
Well, let me just follow up on that. I think from a policy perspective, what we're seeing is the learning curve, they call it. It's how does the production come up to economies of scale and learn how to do it and get it, so it's really a cost curve. For storage is echoing that of solar and wind. So the cost for batteries now is far lower than anybody 5 years ago projected they ever would be. Just like solar being less than $1 a watt to install. Never gonna get there.
What is the cost of that?
I'll turn to Nick for that, but you can look for continued reductions, either reductions in the cost for a given battery or the same cost for a much better, bigger, longer battery. Moore's law applied to computer chips. It really is applied to solar as well. Nick mentioned that the average default panel is now 400. Mine are 250s. And they were only installed in 2014. So that shows you what's going on. And they cost less than mine did. So the same's happening in batteries. I don't wanna say wait a while, cause you got the 30% now, tax credit. So there's still some decisions to be made, but it won't be long before you can look at solar or wind and batteries, much like you today look at your iPhone as giving you an immense amount of freedom compared to the old phones that we were all aware of, went into the wall. And they're only 12 years old. That change in society is only 12 years. Likewise, laptops, right? I used to be a data processing manager once upon a time, and it's not centralized anymore. And that's happening, those same forces are at play in the power sector. Freedom's coming. How much is a battery?
So that's a tricky question, same as a solar system. So the Tesla Powerwall that I showed, we install those at an install price of 17,000. So they are quite expensive, but you don't always need that much storage. That gives you 13.5 kilowatt hours of usable storage. Overkill for a lot of people, you can go as low as 5 or even 3 kilowatt hours, and still take advantage of the battery backup system and get your price under 10,000. The tax credit applies to batteries so long as they're being charged from a renewable resource such as solar panels. Yes, ma'am.
If an individual's considering going off-grid, not getting rid of the relationship with Versant, do all the financial incentives / rewards disappear?
So she's asking if someone's trying to go off-grid, do all the incentives remain? The federal tax credit still remains for off-grid systems. So that includes not only the components, but the labor. So if you hire someone out, that will be included. So yes, you still have all those incentives available to you. Yes, sir.
This is obviously somewhat of a political question, but is there any indication that this 30% tax credit is going to go away in the next year or two, or how long is it scheduled to remain?
So he's asking about how long the federal tax credit is scheduled to remain for. The passing of the Inflation Reduction Act extended it until 2032, and it will remain at 30%. So when that act passed, the tax credit was actually 26%, set to go down to 22%. And when that act was put into place, they increased it to 30%, retroactive for that year as well, and extended it to 2032. So you also can roll over your tax credit until 2032 as well. So if you can't take advantage of that whole credit in year 1 or even year 2, 3, or 4, you have plenty of time to take advantage of the full credit.
Nick, being more of a policy geek and less of an engineer, let me also suggest though that laws can be changed. And not only is there legislation, the laws, but there's also the appropriation to actually pay for the things the government said it was going to do. And a subsequent government can not appropriate the money that the prior government promised would be spent. So
This
there,
is not an executive order.
it's not it's a statute.
So you actually have to pass.
Yes, yeah, there was a statute, bill, law, yeah. Question back?
If somebody already is doing net metering, can you add panels, or if you add panels, do you need to apply for another permit to do that, or can you somehow?
Yeah, so yes and no. So, oh, I'm sorry. So the question was, when you add more panels and you're already enrolled in the net energy billing program, do you have to reapply? And that depends on how your system was set up. So if you add just more panels, DC power to your system, you do not need to reapply. If you add AC power, which is more inverters to your system, then you do need to apply. And the reason for that is that the output of your system will never exceed that of your inverters. So they only care if you're actually increasing the AC size of your system. So you would need to do a whole new application if you added more inverters, more microinverters, or increase the AC size of your system. But one way we kind of get around this and more plan for the future, if someone does think they want more panels in the future, we just give them a larger inverter right off the bat so you can easily upgrade, and then you don't have to worry about that application process again.
Could I just bring up one point that I'm hearing from Kate, and that's the idea of getting off the grid. it's hard to overemphasize the value of being grid tied financially. If you're off the grid, then your solar and battery system needs to be sized for your maximum loads of the year, which happen about now, just when the sun is the least powerful. So you, in order to be off the grid, you need an enormously bigger solar array. Then in the summertime, you make a tremendous amount of power that you don't get any benefit from because the days are so much longer, the sun is so much higher. The benefit of net energy billing is that you can use the summer's solar gain as a bank account to be drawn from in the winter, so your entire system can be much smaller and much cheaper. Thank you.
Yes, sir.
It's related to that point. I'm not an expert on this, but I did hear in the limit, when everybody has got their solar arrays and their cars as their battery, sounds really cool. The power company isn't making any money. And I'm pretty sure it was Hawaii where they already hit this point. The subsidies go away because of what was just said. You need the grid there all the time, so they have to pay for that. So there's some point in the future, if everyone is successful at this with these lines crossed, then can you predict when instead of you getting money back from or saving money, you're going to be paying for the privilege of the backup power of the grid? When is that coming?
The question is, the grid has a value, but at this point, we, as net meterers, don't have to pay for it because we get a 1-for-1 trade for kilowatt hours that we put in at some point versus those what we use, which may be at a different point in the day. When is that likely to change? I don't know how to handicap the when, but I want to take a little bit of the fear away from it. I'm, as I said, a net meter myself, but I was also, before retiring, an energy advisor and policy geek. And I think I should pay more for the benefit of having the grid, what Doug described, than I do now. And there's evidence of at least one approach on that. Prior to moving to Maine a decade ago, I was in New Hampshire, so I was a Westerner, and I was on the board of New Hampshire Electric Cooperative. New Hampshire Electric Cooperative encountered its a cap for net metering, which was a legislative cap. You have to do a 1-for-1 up until this cap. Well, we reached that cap, the fastest utility in the state. There was nothing in the bill, in the legislation about what you do at that point. So we could tell our members, but they were members, not customers of the co-op, to pound sand. Well, that's the wrong answer when they're your members. We could continue it, which has the problem that you described, that there are costs. Now, how are these to be paid for? And what we ended up doing was saying, look, at the time, power was about 16 cents at retail. You would be paying about 16 cents. We said up to the cap, we owe you 16 cents. The legislature said we got to do that. But at this point, let's figure this out. We owe you for the kilowatt hour because we didn't have to buy one. We owe you for the transmission because we didn't have to have it sent to New Hampshire. That's about 8 cents. So we owe you 8 cents. Now, solar, there's a lot of benefits to solar that many of which are hard to quantify. The emissions reductions, the localness of it, the local economy benefit, installers and so forth, people like Nick's job, right? But we also need to be able to support the poles and wires and answer the phone. So let's split the other 8 cents. So how about you get 12 cents and we keep 4? And that was the way New Hampshire Electric Cooperative marched forward. Seemed pretty reasonable to me. Vermont had a similar case with a co-op up there. They had to put it through their PUC, but they came out in essentially the same place. Well, that'd be all right with me. I want that grid there so that I don't have to have huge batteries or a diesel generator.
It's just that I've heard complaints in the one article I read where it happened, the people buying got surprised. That was, they had factored in a certain return and it shifted because they weren't getting as much benefit.
Yeah.
That was something.
It's an early adopter versus late adopter kind of thing. Yeah, the early adopters take a bigger risk. I'm in with 250-watt panels and you could get 400. But they also have the more likelihood of that initial policy reward. When everybody's got solar, what's the incentive to have solar? The government rebate incentive. Now, there's still lots of environmental incentives and climate incentives.
We should be so lucky as to have that problem.
Bingo.
Does anyone know what the situation is as far as the Brooklyn school going solar?
The Brooklyn School is on the wrong side of the peninsula.
I have no sense of that. So Doug's, the question is, what about the school and what about its hope or opportunity to go? So, one small thought I would contribute is that, if you're the town and you're talking about your school or your town hall, that is a much better case to go to Versant with or go to the PUC with than I got my house and I want it sold. Yeah, who are you? Go away and bother me. I got a to-do list to do. But if you're talking your school and you're talking your fire station, you're talking town hall, that's a different story. Kind of got to pay attention to that. Brooklyn's got a representative, that representative talks, that representative votes, you know.
Seems like that grid part that we're having the problem with, it makes the turn, like it comes to the center of town and goes to Mascot, is that the good side and then the bad side is from there over, or is it just West Brooklyn?
So the question is, where's the cutoff for the two different circuits? Me not being super familiar with, the town of Brooklyn, it's kind of towards the south is a cutoff right in the middle. I'm just looking at it from the map where you have the cutoff of BL2 circuit, which is bad on the eastern side, and then BV2, which is the better circuit. And, at this point, it could be all out. There could be no more interconnection availability there. From our experience, we have had projects pass on that circuit. It goes all the way down to Deer Isle, the same circuit. So I would suggest you go onto Versant's hosting capacity map and see for yourself. You can just click on wherever you're located and it'll tell you what the circuit is. It says BL2, it's bad.
My thought process was, I don't know that much, but looking at the power lines coming into town from West Brooklyn, the 3-phase lines run in, nice heavy lines all the way into town and then go down Mascot, maybe as far as Wooden Boat. And I kind of surmised maybe that was that other grid, partially because sometimes West Brooklyn loses power when I don't, but I don't know where that cutoff is. But it seems like if there were a small upgrade through town, past the fire station, past the school, maybe as far as that road, the old county road, that you would get the center of town back into that, and that the school could do something, the fire station could do something. The town maybe could pony up something for that.
The question was, could a small increase, improvement in the grid really yield some substantial benefit for the town? That's where your 100,000 may actually make a big difference. Yeah, short answer is yes. Yeah. I think we've exhausted.
Thank you to Nick and Ken for some great insight into how our grid works and how we can be part of it.
Well, thank you on behalf of both of us, or Nick may also have a closing thought. But I would just opine that a group this size in a town this small is itself a significant message. So I hope you've perhaps taken some pictures or logged some attendees or whatever else, because this is a meaningful step right here now today, and you're on the right path. There are these obstacles, but they'll eventually fall. So thanks for doing what you're doing, and thanks for coming tonight. Nick and I, Doug knows how to find us, so this isn't the end of the story. If you have other thoughts or questions, don't hesitate.
Yes, thank you guys all so much for coming out. I was very grateful for the opportunity to speak here today. So thank you to the Brooklyn Climate Committee for allowing me to speak tonight. It's unfortunate that we're in an area where there's a lot of people passionate about going solar who can't do so. So I would say if you are one of those people and you are interested in going solar, contact the Public Utilities Commission, contact Versant, let them know that you're here, you want solar, and that you want something to be done about it. So that's the best we can do right now, and I think that's a great step forward.
Thank you. You two are a great team. I know Sundog well, but haven't met Nick. Nice job with the presentation. Yes. And thank you for making the trek over here. I really appreciate it. Well, pleasure. I didn't anticipate that you might live 10 feet.
Well,
I was hoping.
it's gotten a little better.